Howdy, sixth grade. Hopefully you're enjoying your time back at school. We've got 3 days of e-learning here. So I've got this little video. We're going to talk about some stuff here, some stuff you're going to like, mostly because part of it you get to do some stuff mentally, which I know some of you very much enjoy, even though you're not supposed to do. So we're going to talk about that. If you would grab your notes, the first thing we're going to do is we're going to talk expanded notation again. You should already have some notes on that. So if you would look in your notes and find that piece of paper. If you can't find that piece of paper, I guess you can start from scratch. But we're going to talk about expanded notation and what to do when you end up with some decimals in expanded notation. So here we go. Let's write that up top here. Expanded notation. Let me do an example of what we've done first, just to jog your memory. For example, if we were to write 2080 in expanded notation. Remember, that was simply doing this. We're actually looking at what place value these digits are all in. The 2 is in the thousands place. So when we write this in expanded notation, we would do 2 times 1,000. Put that in parentheses. And to that we would add 8, which is in the tens place, 8 times 10. So this was our expanded notation. Well, we're going to do that same thing, except now we are going to look at what happens when we have some decimals there. For example, if the directions said to write 5.06 in expanded notation. Okay, what you have to remember is, what do the decimal place values? You know the 5 is in the ones place. This 0 is in the tenths place. And the way we kind of show that in expanded notation is with fractions. And remember, the tenths place just means you have some number over 10. So this would be 0 over 10. So I don't have to show that because it's really nothing. The 6 is in the hundredths place, which means it is 6 over 100, 6 hundredths. So if I'm writing this number, 5.06, 5 and 6 hundredths in expanded notation, I would write it as such. The 5 is in the ones place, or the units place. And to that I am adding a 6 in the hundredths place, or the 6 in the 100ths place. So you have to write the decimals in expanded notation as fractions. Let's look at another one. Let's say I had 35.342. It's going to be kind of a long one, but hey, you're sixth graders, you can handle it. It would be 3 in the tens place, so 3 times 10, plus, again, a 5 in the ones place, so it's 5 times 1, plus this 3 is in the 1/10ths place, so it's 3 times 1/10, plus 4 in the hundredths place, so it's 1 over 100, and then the 2 is in the thousands place, so it's plus 2 times 1,000. 2 times 1, 1,000. So there is your expanded notation with decimals. And we also have to go over what happens, you know, just like we did before with regular numbers. We have to change expanded notation back into standard form. So let's look at what would happen for that. If I said to do this, write, let's see what we have here. 4 times 1/10 plus 7 times 100 in standard form. Okay, so the first thing we know here is there is no whole number. The first thing we have is a decimal, so you don't have any whole number, so we're just going to put a 0 for the whole number and then put our decimal point. This 4 happens to be in the 10th place, so I put a 4 in the 10th place, and the 7 happens to be in the 100th place, so 0.47 would be my standard form of that expanded notation thing. And let's not forget, let's do another one. What if I had, let's do 7 times 100 plus 6 times 100th. And if I were asking you to write that in standard notation or standard form, remember the 7 has to be in the hundreds place. So in order for that to happen, we have to have something in the tenths place and something in the units place. Then we have our decimal. The 6 is in the hundreds place, so I'm missing something in the tenths place. So my 6 would have to go there. Remember, you have to fill in these empty spaces with zeros. So 7 in the hundreds place plus 6 in the hundreds place would end up being this number in standard form. So there you have it. Hopefully that helps you out. We're not quite done yet. We've got one more thing to cover. This comes from lesson number, I'm not sure what we're at, lesson maybe 46. But you'll like this one. Take out your notes under decimals. We're doing a little bit more decimal work today. Under decimals. And under decimals, today we are looking at what happens when we multiply decimals by 10 or 100 or 1,000. By 10 or 100 or 1,000, I'll give you a chance to catch up with me on that, because maybe you had to find your decimal notes and it might take a while, because I've seen some of your notes. Now, the reason why this should make you very, very excited is because this is one of the incredibly few times ever that your teacher and your book will tell you that you can do these mentally. Which means, boys and girls, you don't need to show any work. As a matter of fact, this would be one of the few times I would probably kind of yell at you, and I won't yell, but obviously scold you, because if you actually do try to do these out, it can make things way, way, way confusing. But let's look at a couple examples. And what we mean by multiplying by 10 or 100 or 1,000 is, let's say this is our example. Let's say I have 3.52 times 10. Okay, if I'm doing that out, I get 3.52. I'm going to multiply it by 10. I guess I can let that 0 hang out. I get 0. 1 times 2 is 2. 1 times 5 is 5. 1 times 3 is 3. You know, we count decimal places when we multiply by decimals, and there's 2 there, there's none there, so I come back 2 places. So my answer happens to be 35.2. Well, let's just for fun take this same number, 3.52, and multiply it by 100. Okay, so first of all, I got this to be 35.2. Now, if I do 3.52 times 100, again, I'll drop out those zeros, I'll bring them down, I'll multiply by 1 times 2 is 2, 1 times 5 is 5, 1 times 3 is 3. So I get this, and again, there are 2 decimal places there, there's none there, so I come back 2 places, and my answer is 352. So my answer to this is 352. Now, what you will notice, children, is this. Look at, when I multiply by tens or hundreds or even 1,000s, the digits don't change. You know, I have a 3, a 5, and a 2. I got a 3, a 5, and a 2. I have a 3, a 5, and a 2. I have a 3, a 5, and a 2. The only thing is that the decimal moves. And if you look at this first example we did here, I multiplied by 10, and the decimal went from here to here. It moved one place. When I multiplied by 100, the decimal moved two places, which got me 352. Well, if I were to multiply, I'm sorry about that. If I were to multiply by 3.52 and multiply by 1,000, I am going to move the decimal not one, not two, but three places. 1, 2, 3. And I would actually have to add a 0 to this because I ran out of places to move the decimal, and it would end up right there. So the rule, and we're going to write this down because it's always good to write rules down. Here is our rule. And this would be one of those things that I would tell you to write in ginormous letters because this is something that you need to know and take with you forever. The rule is this. When you multiply by tens, 100s, 1,000, or anyone with any number of zeros, you just need to move the decimal to the, I'll make sure you write this in big letters, to the right. As many places as zeros in the 10, 100, 1,000. Okay. When you multiply by 10, 100, or 1,000, you simply have to move the decimal to the right as many places as zeros there are in 10, 100, or 1,000. Please understand, you are not simply adding zeros like you do when you multiply whole numbers. For example, now this is what I'm talking about. If I had 58 times 10, yes, I get 580. Okay, but you can't just do that with decimals. In essence, if you think about the rule we just wrote down, where was the decimal in 58? It was right here. I did move it one place to the right, and that's where my 580 came from. But don't just simply add zeros and then call it a day and say that's my answer, because you will get that wrong. So here we go. Let's do a couple examples. Let's say I have this 0.125 times 10. Now, the book, again, you will know that you can do this mentally because the book will say, let me look at the exact words. The book says mentally calculate. Mentally calculate. That means do it mentally. Mentally calculate. Which means you can use your own noggin as a calculator. Now, please understand this also, 6th grade. I need to emphasize this. When the book tells you to mentally calculate, that does not mean you just write the answer. Okay, I need to see you. You need to write the problem down on your piece of paper. I need to see this. But all you can do after that is just go put an equal sign, and you say, oh, 1, 0. I move the decimal one place to the right, so my answer is 1.25. I don't just want to see the 1.25. I need to see the problem written out, but you don't have to do any work with it. You just do and get your answer mentally. Same thing as if the problem said to do this. What if it was 0.125 times 100? 2 zeros, move the decimal 2 places. My answer is 12.5. Okay. Got that? I do need to see the problem. Now, how about a couple more examples? 2.5 times 10, and let's do 2.5 times 100. In this case, 1, 0, move the decimal one place right, so my answer is 25. In this case here, I have 2 zeros. I move it 2 places, which means, because I only have 1 place there, I'm going to have to add a 0, I get 250. Or just for fun, what if it was 2.5 times 1,000? 3 zeros means I move it 3 places, which means in this case I am going to have to add 2 zeros to come up with all my places. So hopefully, 6th graders, you found that relatively easy. Again, this is one of those very, very few times when doing mentally is actually going to help you, because if you went back to all this gobbledygook I did up here, sometimes people get way confused because they start dealing with putting zeros down and counting decimal places and blah, blah, blah. This is just much, much, much simpler. Well, I thank you for tuning in, 6th grade. It's been a pleasure and a delight. And have yourself a great day.